that we need to understand. But like Sarah said, if you have any questions, put those in the Q&A, and I will do my best to answer them at the end. So first, who cares about the life beneath our feet? Well, it seems like plants do. And so if you want to grow plants, you probably should too. Um, there's some really interesting studies that have been done looking at kind of where plants allocate the energy that they produce. So, the sun hits the plant and they photosynthesize and do their magic and turn sun and air into solid molecules of food, which is wild. But they use that, to build their leaves, their branches, their roots, but they have to allocate it in different ways. And there's been some really interesting studies to see kind of where the energy goes in terms of, is it staying above ground to grow leaves? Is it going below ground to grow roots? And it varies by plant, but these numbers here are the percentage that goes below the soil surface. So for weeds, it's only 20%. But for things like grains and row crops, it's about 60% of the energy goes below the soil surface. For vegetables, it's 75% goes below the soil surface. So like stuff you don't even see. And for shrubs and trees, it's 80 to 85%. So when you see a tree, you're only seeing, 10 to, what is it? 15 to 20% of all the energy went to produce that. All the rest of the energy went below ground. But what's wild is when they then do studies to look at like how much root material is there. Only about half of the energy that is going below the soil is accounted for. The other half is not in the plant at all. It's actually getting released into the soil. The plant is pushing it out into the soil around it. But where is that energy going then? Like, I mean, that seems like a pretty weird design. If a plant is like, I'm going to make all this energy and, exhaust all of these resources and then just like let it leak out into the soil around me. So that energy that's going out is called exudates. So the plants actually release exudates above ground as well, but most of it is coming out of their roots and going into the soil. And it's things like sugars, more complex carbohydrates, amino acids, and other things that we would kind of identify as food. And so these are things that living things eat. Water isn't like, ooh, I really need a sugar fix. And a sand particle isn't like, man, I really need some more amino acids to get some more muscles building or something. These are things that are not using it. Life in the soil is the only thing that could be utilizing these components. So then, how much life is there? That's like for trees and plants, 50% of 80%. That's almost half of all of the energy that these plants are producing. They're giving to this life in the soil. So like, how much is there? Like, what are we talking about? So first, if we look at soil more generally, kind of what is it? We kind of got to know that to know how much life there is. And soil is a combination of components. It's a bunch of different things. And the exact ratios of those components can vary really quite a lot depending on the situation and the location. But kind of an idealized soil, like general kind of numbers, are a good healthy soil should be 50% pore space. So not the things we even think of as soil. So like a place for air or water to reside in the soil. So kind of gaps between those solid particles. And then the other 50% is that solid material. So 45 to 48% is solid material of sand, silt, and clay, which is when people are talking about what type of soil they have, they say, oh, I have a clay soil, or I have a sandy loam, or I have a, clay loam, or whatever people say. That's what they're talking about, is they're talking about that 45 to 48% and kind of the ratios that they're in. And this chart over here is kind of the classic chart of that, showing what those different ratios mean, kind of what we've come up to call those different ratios. And only about 2 to 5% of soil is a thing called organic matter. So organic matter is living and formally living compounds. So organic matter includes the living root that's in the soil, but it also includes the dead root that's rotting. It includes the long dead, bit of plant material that was turned into humus, and it's all of those dead compounds. And it's that 2 to 5% is really all we're going to be talking about with the soil today, which again seems like a pretty small amount. And if we look at that to figure out like how much of that is actually life, like the soil life that we're talking about, A third to about half of soil organic matter is stabilized organic matter. So it's things like humus, which are not really um, doing a whole lot. They're not the things that are actively decomposing. They're pretty stable. Like humus molecules can stay in the soil for hundreds of years. Um, they are active to some degree, but very, very slowly changing in the soil. About a third to half is decomposing organic matter. So that's the active stuff. So that's the compost that, if you add compost to your soil and then it's like, oh, I need to add more, like where'd the compost go? That's the active stuff. It's the stuff that's actively still decomposing. It's the stuff that earthworms and everything are kind of churning and making rot faster. Less than 10% of it is fresh residue. So that's like when you look at your garden and there's like a dead tomato leaf from last year that you can still identify, like that's considered fresh residue. And then less than 5% is living organisms. So when we're talking about the life beneath our feet, we're talking about 0.1 to 0.25% of the soil. And plants commit 10 to 42% of all of their energy to feeding 0.1 to 0.25% of the soil, which is kind of a crazy concept. Like if they're investing that much, it must be pretty important because they're just giving away this food seemingly. So what is this life like? Just so we know what we're dealing with here. So kind of these are the main classes that we'll be talking about in terms of, and not in depth, but bacteria and fungi are really the ones that we're going to be looking to encourage and how to encourage. But then there's things like protozoa, nematodes, microarthropods, and earthworms that are also important in the soil. And there's other kind of bigger creatures, but we're not really going to address those. So why would plants feed soil life? Like why would they do that? Is it just charity, or do they just do they have like pet fungi? Like what are they doing? So there's a couple different things that the life in the soil does for plants, essentially, and that they do for the soil that benefit plants. And one of the first ones is soil life builds structure in the soil. So bacteria in particular are incredibly small, and they feed primarily they're eating the sugars, the exudates from the plant roots, but they are also getting minerals. So the plant is not giving bacteria minerals. It is not giving bacteria, calcium and magnesium and molybdenum and, all those other things that living organisms need. So the bacteria needs to get that themselves. And the way they do that is bacteria glue themselves to a mineral particle, a piece of sand, silt, clay, or organic matter. But these sand, silts, and clays, they literally can glue themselves to it. They produce these glues and they release enzymes that slowly dissolve those minerals so that they can absorb them into their body. And so when they do that, they're glued to one, and then more bacteria come along, and there's like kind of a cluster of bacteria all glued here. And then, they bump into another particle of sand, silt, or clay, and then they're glued to that one too. And so now there's two particles kind of floating out in there. And then there's bacteria that grow, and then they run into another one, and you get these kind of clumps, like little clumps of mineral particles that are sticking together. So that's what we call a microaggregate. And then you have fungi that have these long hypha, that are these long kind of mycelium. So this white stuff that you see in this picture. So, it's big enough that you can see it with your eye. So, much bigger than a bacteria. You can't see bacteria. Even with microscopes, they're pretty tiny. But, fungi, you can see a hypha right there, that kind of white filament. And so they can go along and they can tie bigger things together. So, bacteria making these little clumps, and then fungi are attaching a bunch of those little clumps together to make macro aggregates. And kind of an example of that you can think of is this picture here. Or if you've ever had a pile of wood chips and you let it sit for a while, like several months, a while, or even longer, and then you go to dig into it, a lot of times the chips are not just completely free, independent chips anymore. A lot of times you'll get these kind of like big clumps, like they're almost kind of like stuck together, sometimes in really significant clumps. And a lot of times when you look at it, it's because you see those little white kind of strands in there, and that's those fungi creating essentially macro aggregates of wood chips. So they're doing that same thing in the soil. And the benefit to that is having kind of creating those structures is you're increasing the pore space in the soil. So clay particles are really, really tiny. And if there's nothing kind of putting them into clumps, they will pack together really small, and you don't actually get a lot of water um, that can stay in there, and your soil will get waterlogged really quick. It's why clay soils are notorious for having really slow drainage. Generally, that really slow drainage is indication that you don't have much life in your soil. You don't have things making those clay particles into micro and macro aggregates to increase the drainage. And so creating that pore space helps prevent compaction, because especially with the fungi are kind of spongy. I mean, if you feel a mushroom, they're kind of like spongy, little elastic. So, if something comes along and steps on the soil and kind of smashes that aggregate, but there's all those little spongy fungal hyphae between all those particles. When the weight comes off, it's more likely to just spring back, as opposed to if it's just soil, you smash it, it's smashed. It also allows more water to be held in the soil by creating those bigger gaps. There's more water that can be held in the soil, which is good. We want our plants to have water all the time, hopefully. It also allows oxygen to go deeper into the soil, and roots need oxygen, and the life in the soil needs oxygen as well. So they help with that. They can also directly and indirectly help suppress disease organisms. So having kind of a rich diversity of organisms competing with your disease organisms decreases the chance that disease will be able to take over. So it's kind of the theory of probiotics or stuff like that. Even if you have lots of things that are not going to cause a disease, they are kind of taking up all the space, eating up all the exudates, all the food. It's going to be harder if a disease comes along to be able to find a spot, to find a home. There's no room at the inn when it shows up. It's kind of the hope. And there's some organisms in the soil that quite literally will trap pests. So this is actually, this white thing here with these little donuts around it is actually a type of fungi. And this big thing here is a root feeding nematode. And these little things, they're like inflatable. It's wild. They're like inflatable, where it looks like a little ball kind of here. So these kind of flatten out, and when the fungus feels a nematode touch this, it'll basically inflate those to trap it. And eventually the nematode will die from exhaustion from trying to get out, and then the fungus will eat it. And they've done studies and found that these really only seem to attack, for the most part, the root feeding nematodes. They don't really attack the nematodes that are not a problem. So the soil life can have indirect and pretty direct benefits. But arguably the most important thing, or the most obvious benefit, is that they can actually feed your plants. So fungi and bacteria, like I talked about a little bit with the bacteria, make compounds that allow them to solubilize the minerals in the soil. So a root cannot absorb a clay particle. It can't absorb a clay particle, which is essentially a tiny rock. Just like if you eat a rock, it's not gonna satisfy your calcium needs. It needs to be made into a bioavailable form. And the bacteria and the fungi are able to do that. They're able to create enzymes and acids that can dissolve that rock, and they can bring it into their body and make it bioavailable. And in some instances, like mycorrhizal fungi, which an increasing number of people know about, they're solubilizing those nutrients and just directly sending it to the plant. Like they can actually create a relationship with the plant, and they'll just directly shoot those minerals to the plant, and then the plant will directly give it sugars. But more generally, what happens is the bacteria and the fungi are out there doing their thing, solubilizing these minerals. And then when something comes along and eats that bacteria or fungi, something like a nematode, a protozoa, a microarthropod, or an earthworm, the waste of that predator becomes available nutrients. It's essentially micro manure. So you can think about it in the same way like worm castings, which a lot of people know, a lot of gardeners have started using. That worms actually don't eat organic matter. They eat all of the bacteria and fungi that grow on the organic matter that goes through their body. So the worm casting is actually the stuff from the bacteria and fungi in the soil. And it's the same on a smaller degree with nematodes and protozoa. Their waste is like a mini worm casting. It's just really tiny manure. And bacteria and fungi have much higher amounts of nutrients in them than a nematode and a protozoa and a worm. And so their waste has a lot of nutrients still in them. So again, I mean, it's just like cow manure or horse manure. Like if you're applying those things, it's doing kind of the same thing as these organisms do for the plant without having to hope an animal comes along. So where are these organisms in the soil? Just a little kind of interesting thing here. They are throughout the soil. They're kind of all over the place, but they are at their highest concentrations where the food is. And mostly the food is right around the plant roots. So, the plant is leaching it right out there. So in those, couple little micrometers around a root is where the majority of the plant life is, because that's where the majority of the food is coming from. It's where the majority of those sugars and proteins and enzymes and stuff are coming from the plant. And what's particularly wild is plants can actually change the composition of the exudates that they're leaching into the soil to increase and kind of by default decrease organisms that they do and do not want. So fungi can break down more complex molecules than bacteria. Bacteria really like sugars. So if a plant really needs what bacteria are best able to offer, they'll release more sugars and less amino acids. If a plant needs more of the things that fungi are better able to provide, they'll bump down the amount of sugars they're putting out into the soil, and they'll bump up the amount of amino acids and lipids and other more complex molecules to shut off the spigot to the bacteria so their populations start decreasing, and to bump up the populations of the fungi. So plants are actually able to manipulate the life in the soil to get them what they need in some regards. So what different organisms, what things are they going to kind of push and pull, get more of and less of? And I kind of already said this, but bacteria and fungus are the main two categories. Protozoa and nematodes and stuff like that they're really only making the nutrients available by eating bacteria and fungi. So they're important, but they're not the ones actually providing the nutrients directly. They're not the ones that are able to make the nutrients available from the rocks. They're not able to take them from the rocks. And one of the reasons why plants will kind of push or pull bacteria or fungi is that, bacteria fungi, is that bacteria and fungi produce different forms of nitrogen. So fungus are primarily creating ammonium, and bacteria take ammonium and turn it into nitrate. So if a plant really likes nitrate, they're going to generally want more bacteria in the soil. If a plant is able to utilize and kind of prefers ammonium, they're going to usually want more fungus in the soil, because nitrogen is kind of the most limiting nutrient that there is. So that's kind of a pretty good indicator of what they're going to want more of. And so there's been lots of studies that have been done to kind of look at, well, what can we kind of figure out which one plants want, so we're not just being like, wonder what this apple tree wants, to kind of look at, are there general categories? Do kind of the same kinds of plants like similar soils? And it's kind of been broken down into a couple of different categories. And these are kind of listed by increasing love of fungus, basically. It's also interestingly kind of a succession. Like if you know about ecological succession, if you think back to any ecology or environmental science classes you did, kind of that idea of like, you start with bare soil, and then usually you'll have annuals and weeds and stuff, and then you'll have more perennial grasses, and then shrubs will come in, and then trees will come in, and that's not always the case, but usually things kind of move in that way. And you can see that happening, in like a vacant lot or like a demolition site, if you're in a more urban area, or if you're in a more rural area. You see a cornfield that's been abandoned for a couple of years, you can see the same thing playing out. It's pretty universal in a lot of ways. And it turns out that succession in a lot of ways is driven by the bacterial to fungal ratio. So when soils are laid bare, almost all the fungus is killed off. And so you get it's very bacterially dominated. And so what likes soils that are very bacterially dominated are weeds. Weeds really like bacterially dominant soil. They don't really like what fungus have to offer. And a lot of weeds, actually, if they get inoculated with a mycorrhizal fungi, the mycorrhizal fungi can actually kill it. They don't like fungus really at all. Weeds really like bacteria, so they only want like one, and this is by weight, this ratio. So they only want like 1 part fungus to 10 parts bacteria. So mostly bacteria. And then kind of the next one up is you get to early grasses. So kind of the weedy annual grasses that you'll see growing around, like foxtail grass, that thing that's kind of got the little puffy kind of foxtail looking seed head on it. But it also includes things like Bermuda grass and bromes. And in the garden, it includes things like brassicas and mustards. And so that includes, so brassicas include, your cabbage, kale, collards, broccoli, and then your mustards include not only mustard greens, but it also includes your turnips, your radishes. Um, so kind of those spicy flavored greens, bok choy, tatsoi, a lot of the Asian greens are mustards. And they like a little bit more fungus. So they like about 3 parts fungus to 10 parts bacteria, but still very bacterially dominated. If you look at that, they still don't like a whole lot of fungus. And they're the same where they do not like mycorrhizal fungi. Mycorrhizal fungi actually act as a parasite on them. They can't utilize what mycorrhizal fungi have to offer them at all. And then a little bit further along, you get things like mid grasses. So a lot of lawn grasses other than Bermuda are kind of mid succession grasses, and your vegetables. So your vegetables other than brassicas and mustard, for the most part, like a more balanced kind of 3 parts fungus to 4 part bacteria. So still more bacteria than fungus, but getting a little closer. And then a little higher or a little more fungus, you get like late successional grasses. So a lot of your like long-lived prairie grasses and things like that. And then a lot of our row crops like rye, barley, wheat, oats, corn, they like a 3 to 4 all the way up to kind of a 1 to 1, pretty even split. And then things like shrubs, vines, cane fruits like blackberries and raspberries, they want more fungus than bacteria. They want 2 parts fungus to 1 part bacteria, up to 5 to 1. And then deciduous trees, so that's all the trees that lose their leaves, including our fruit trees. They want a 5 to 1 to a 100 to 1. And then when you get to old growth forests, like coniferous, if you get out to like the West Coast, Rocky Mountains, stuff like that, they want mostly fungus. They don't really want any bacteria at all. They want 100 to 1 up to 1,000 to 1 ratio. And this fungal to bacterial ratio, there's been some interesting studies I've heard from an NRCS soil specialist that he doesn't even use NPK tests anymore. Like he doesn't even do soil nutrient tests anymore because he finds the fungal to bacterial ratio is more meaningful in terms of how productive the soil is going to be, which is wild. And there was one study that was done in New Mexico from a guy who's been looking at this, where he looked at pepper plants and found that the fungal to bacterial ratio had an 88% correlation with yield, whereas the NPK levels in the soil, so the nitrogen, phosphorus, potassium levels in the soil, only had a 5% correlation. So that's quite a difference. And yet the NPK levels is what we have been using to test our soils for like 200 years. And it's what the whole fertilizer industry is based on, is NPK levels being really important to yield. And so this fungal to bacterial ratio is unique, and it can be used, to help you kind of figure out what's going on in your soil. So, if you've got, if you say, I want to plant some apples, I really want to grow some apples, and I'm going to grow them in this vacant lot that is all Bermuda grass. And I'm going to dig a hole and I'm going to stick my apple tree in and I'm going to water it, and it should grow, right? Like, why not? It's getting sun, it's getting water. Our climate is good for it, and then it just doesn't really grow. And you're like, why is this not really growing? Well, if the Bermuda grass has been growing there for a long time, and remember we talked about earlier that plants release the chemicals that promote the bacteria or the fungus that they want, the Bermuda has basically created the soil that it wants, which is like a 3 to 10 ratio. And you stick that apple tree in, which wants a 5 to 1 to a 100 to 1 ratio. So very different. And the Bermuda grass in that situation only has to hold the status quo. The apple tree has to fight to change it. And it's much, much easier to hold a status quo than it is to make change. And so you need to basically help that apple tree if you want it to thrive. Or you could look at it and say, well, I've already got Bermuda grass. It's going to be a struggle. So maybe instead of an apple tree, if I want fruits, I should instead do a shrub fruit, which isn't going to be quite as much of a fight. or if you're in your vegetable garden and you're like, my brassicas and my greens and my, stuff like that grows really well, but my tomatoes are just never great. Um, Maybe it's because you need more sun or more water or something like that. Or maybe it's because there's just not enough fungus. I mean, maybe the tomatoes just aren't thriving because the soil just isn't quite what they like. And so maybe, then you need to look at it and say, well, I need to make it more fungally dominated if I really want more tomatoes, or I need to make a new bed and make that one more fungally dominated. So it can help you kind of figure out what's going on with your soil and figure out what you need to do to make it more healthy. That the answer isn't necessarily just buying fertilizers or buying compost or purchasing these products. So which comes first, the plant or the fungal to bacterial ratio? Because like I said, they like to grow in these soils, but also they can release these chemicals to encourage um, the bacteria or the fungus they like? And the answer is it's a little of both. So it goes a little. There's an interplay between there, and that's kind of how succession works. Is that it can kind of slowly move in that direction. So those weeds, they're releasing those chemicals into the ground to encourage bacteria, but unless you till the soil again, if you've seen a vacant abandoned lot or a cornfield that gets abandoned, it's not weeds forever. Eventually more grasses will come in. Eventually you'll start seeing shrubs grow. Eventually you'll get maple trees growing and stuff like that. So it's a little of both. So how can you impact it then? If it is a little of both, it means that you can have an impact, that you can work to make the soil more what you want it to be, to grow what you want. You're not just beholden to what the soil already is. But the first thing you need to know is what you're already doing that's impacting it. And first of all, almost everything that we do in agriculture kills off life in the soil, and particularly kills fungus. Almost all traditional agricultural practices make soil more bacterially dominated, which is why there's so many weeds. So tilling in particular, disturbing the soil, pulverizes the aggregates in the soil. I mean, it obliterates the aggregates in the soil. That's what most people like about it. They're like, oh, it's so fine and like pretty looking, but that's pulverized soil. I mean, it's been obliterated. And especially when you're thinking about fungus, fungus are big, long strands. If you till it, you're chopping it into a million pieces. And just like you don't like being chopped into a million pieces, the fungus doesn't really enjoy it either. So, I mean, some fungus will survive and be able to regrow, but you're really knocking the fungal population back. Whereas bacteria are so tiny that when you till, you're really killing a pretty small percentage of the bacteria that's in the soil. So tilling, really shifts that ratio. It really drops the fungal population in your soil. Also, salts. Salting the earth is considered it's like a biblical curse. Like you don't want to salt the earth, and yet virtually all mineral fertilizers, and that includes synthetic fertilizers too, are salts. And so they're generally not enough to cause like the biblical curse of salting the earth, but they are toxic to life in the soil. And again, particularly fungi. Fungi are particularly sensitive to salts, and they're also particularly sensitive to sides. So that's herbicides, pesticides. Those are also toxic to soil life, and particularly fungus, especially fungicides. If you're spraying a fungicide on your soil because you have a fungal problem, you're also killing all of the good fungus too. So a lot of these conditions are really selecting against a fungally dominated soil, at least. So if you really want to grow weeds, these are all great techniques. They're also relatively good for brassicas and mustards, but for most other things, if you're wanting to grow trees and berries and even like vegetables other than brassica and mustards, they're not necessarily the best practices. So then what do you actually do? So soil life needs, I put 3 things here. There's a typo. 4 things. So, I mean, they need basically the stuff that all life needs. They need water, they need oxygen, they need food, and they need to be there. You can have water and oxygen and food, but if they're not home, it doesn't matter. They need to be in existence in that space to thrive and grow and create good soil conditions for you. So we'll knock the easy one out first. Water your plants. It's that simple. If you're thinking, oh, it's dry and the plants aren't looking healthy, neither are the super tiny organisms in the soil. You know, they need water just as much. And some of them will die. Some of them can go dormant, and when you water, they'll wake back up. But you are going to lose life in the soil if you're having prolonged kind of dry periods. So keep your stuff watered. And rainwater is the best because it doesn't have you know, chlorine and stuff in it, which, you know, chlorine is a disinfectant, which is why we put it in tap water to kill pathogens, but it also does kill then good things too. Um, but don't stress about that. Like if rainwater is not an option, tap water will be fine. But if you have the option of rainwater, even better. And then oxygen. Oxygen is really important. There are plenty of organisms that can survive in low oxygen conditions, but almost all pathogens are those organisms. Pathogens really like low oxygen conditions. So if you can keep your soils with a high oxygen level, even if there's potentially pathogens in your soil, they're for the most part not going to be doing very well. They're not really going to be able to outcompete the other organisms. So keeping oxygen in your soil really helps the beneficial organisms and makes life for your pathogens that might be there much harder, which is what you want. You want your pathogens' life to be difficult. Um, so there's two main things that really restrict oxygen in your soil. So the first is compaction. So in most vegetable gardens, compaction isn't a huge issue because most of us aren't, you know, driving tractors or cars or you know, running cattle through our vegetable gardens or something like that. But it's one of the reasons why, you know, having like raised beds where you can reach across, where you're not having to step into, can be useful, because when you do step on it, you are compacting the soil. And that compaction, you know, it's the same where you're collapsing those pores, so that, you know, 50% of your soil should be air slash water. You know, water when there's water there, air when it's dry. And so when you step on it, you know, you're not pulverizing and making the sand smaller. You're pushing it closer together. You're just collapsing that 50% that should be air and water space. So, you know, avoiding, you know, not walking on it as often as you need to. You know, if you're running a wheelbarrow through, having, you know, maybe one path, you know, not just running it all over the place or something. Or again, if you have, you know, raised beds, you know, having those walking paths that you can run the wheelbarrow through instead of, you know, setting stuff and packing the soil, can be helpful. And also that compaction, the other thing it does is it reduces how much water your soil can hold. And we want our soils to hold lots of water so that we don't have to water them constantly, so that our plants have plenty of water, so that the life in the soil has plenty of water. And also that collapsing of this pore space increases the chance and the frequency of water logging. So, you know, if you've got standing water, and, you know, again, this is a farm field, not a vegetable garden, but where this water is standing here, if there's water standing on top, it means everything below it is saturated. It means all those pore spaces in the soil below it are 100% water, which means how much oxygen is there in those pores? Zero, which means that there is now no oxygen there, which means it's anaerobic, which means that diseases can grow there. So we don't want standing water. And so, you know, if you're trying to figure out where to plant your fruit tree or your nut tree, probably not there. You know, if that was your yard or something, because that's gonna have more disease in it because you're having that water logging, and compaction adds to that, um, because you're collapsing those pore spaces. So it's gonna be much easier for the system to be overwhelmed and start water logging. So the ways that you can increase the oxygen in the soil, you know, because a lot of times if your soil doesn't have the biology in the soil, doesn't have the fungus and the bacteria, those aggregates have kind of been pulverized through tilling or sprays or whatever. You know, how do you get the oxygen in there? You know, a lot of times people are like, I can't just stop tilling because like the ground is hard as a rock. Like, how am I supposed to plant anything? And so there are a couple ways to do it. So there are mechanical ways. So um, you can till, but you only want to do it once to inoculate, which we'll talk about later. But you don't want to do any regular tillage. You don't want to be tilling every year or twice a year, or like, I mean, it should be like a one and done, or like an emergency fix, essentially. Kind of the kind of annual breaking up of the compaction, or hopefully less often. The best tools for that, well, the best one is really a broad fork, which are a little expensive. So you can also use a digging fork. down here where you're not pulverizing the soil, you're sticking it in and kind of pulling it back, which will kind of crack the soil and kind of lift it up. So you're not mixing the soil, and you usually end up with bigger clumps like this in the picture. So that means you're not pulverizing the fungus. The fungus is still, you are breaking it right at the edges, but it's still alive in there. There's still lots of space. So what you can do then, if you need a nice fine seed bed for something, is you can then apply a nice thin layer of compost. Or, I mean, you could break up just a top little layer here, but you don't want to be tilling like where it's, several inches where you're pulverizing. There's also biological options. So cover crops are great for keeping the soil aerated and for keeping it nice and fluffy, really. I mean, you'd be surprised. And it's because those plants are then feeding the life in your soil. But I'm amazed every year when I do an overwintering cover crop, then in the spring, how I don't really need to break up the soil at all. Like it's nice and crumbly. It's usually soft enough that I can just kind of push a seed in with my finger if I need to. Depending on how severe your compaction is, there's different cover crops that are better at dealing with compaction. One of the best is tillage radish. So this is a picture here that I cropped so you can see it a little better, of a tillage radish that I planted in my own garden. And it's pretty compacted soil. My garden is in an old cornfield that was sprayed and tilled for 150 years. It's hard as a rock dust, basically. But you can see, I mean, there's this big old root, and it just punched its way down and left. I mean, I pulled this one out. So when I pulled it out, there was a big old hole in it that let oxygen and water go down deeper into the soil. Sunflowers have pretty significant tap roots, which you've probably found out if you've ever tried to pull a sunflower kind of stump out. But also grasses, particularly things like Sudan grass, but also rye as like an overwintering crop. So not the annual rye, but the cereal rye. They produce really dense fibrous roots that are really good at kind of breaking up the soil. But really, any cover crop is better than none. But kind of grasses and things like tillage radish and sunflower are some of the best at breaking up compaction specifically. So then the life in your soil needs food. And the primary way that they're going to get food is through the plant roots, hopefully. But in order to do that, you need actively growing plants as much as possible. So, if you're a person that, you really just grow tomatoes and cucumbers in the summer, there's only plants in there for maybe half the year. And then the other half of the year, if the garden bed is empty, what food do those bacteria and fungi have? They have no food for the most part. And so they're going to die. And so then whenever you plant your tomato plant, the plant needs to start all over again. And in fact, plants, when there's less life in the soil, plants actually push more sugars out into the soil. So if there's lots of life already there, they're going to keep more sugars for themselves because they don't need to commit as much to build the populations up, which means they're going to put more energy into growing your food. And so, you want to keep something growing in the soil as long as possible. So, if you're only growing tomatoes, peppers, and eggplants or whatever, if you're not really doing spring and fall stuff, then plant an overwintering cover crop. Like Ryan Vetch is a great one that you can plant in mid-October, and it grows all the way. And usually you're killing it about the second half of April. And then you can plant the tomatoes and, peppers and eggplants, right into the dead cover crop. So you can do, cover crops are great. If you are doing like a spring and summer and fall, doing things like succession planting can be really important. So, doing, planting lettuce, but then, when your lettuce is about to mature or your cabbage is about to mature, plant the tomatoes in there before you harvest it, maybe a week or two before, so that when you, rip those cabbage out, there's already living roots that are there from the tomatoes. And then before you rip your tomatoes out, plant your fall stuff in there too, or do a summer cover crop if you're gonna do spring and fall crops, but not a summer one in that bed. But do lots of cover crops. But their other food source, they're not getting it just from plant roots. Their other food source is organic matter. So, it's one of the reasons why adding compost to your soil can be really beneficial. Compost is organic matter. So having that compost in your soil, but also mulch. So keeping the soil covered helps the biology in the soil a lot. It helps keep it moist. It helps, keep it cool, like when it's really hot in the summer. And it actually helps keep the carbon in the soil. So it helps keep that organic matter in the soil, because the heat of the sun actually can like volatilize the carbon and turn it into CO2, and then it just goes away and you just lost it. So keeping mulch on your soil can also be really beneficial. And kind of the magic number that they found is you need at least 3% organic matter to keep the populations alive when plants are not providing exudates. So, if there's, a couple of weeks gap or all winter gap, if you're not able to get, a winter cover crop in or something like that, what they're going to eat is they're going to eat that organic matter. But what's been found is there needs to be at least 3% organic matter in your soil for there to be enough food for them to make it through that period. Now, most vegetable gardens, 3% is not a problem. It is very easy to get 3%. If you're an in-ground gardener, it's a little harder. But if you're like in a raised bed where you brought in a bunch of soil that already had a bunch of compost in it, and you add a little bit more compost every year, 3% is easy. You've probably already got 3%. But adding that compost so that you make sure that you've got a fair amount of organic matter can really help you with the food. And you want to tailor the food to the crop, because like we said, there's this fungal to bacterial ratio. So you're going to kind of feed different things, just like the plant feeds different things. The actions that you do can also provide foods in different ways to the different, fungus or bacteria that you want. So if your plant wants fungally dominated soil, so like if you're growing a tree, fruit tree, if you're growing a berry bush, or even if you're growing, a tomato plant, but you have lots of weeds, so that you know that there's not enough fungus or something. But just if you're wanting to increase the fungus in your soil, mulching with wood chips, dead tree leaves, or something else that's high in cellulose can really help. Bacteria can't break down cellulose; they can't break down woody materials. Only fungus can. So if you put that food on there, you're only increasing fungus, and that's why dead tree leaves in the fall. I mean, like we think, oh, these trees are just, throwing these leaves down, which they are to protect for winter, but dead tree leaves, great fungal food. They're also feeding the fungus in the soil to keep the soil the way that they want it. They're mulching their own roots and feeding the fungus that will feed them. And so, if you go in the forest, it's all woody leaves. It's mostly fungally dominated soil. And how many weeds do you see in a forest? Not many. Even if you find a spot that's got full of sun, do you see lots of dandelions growing in the woods? No, because they don't like fungally dominated soil. And wood chips are are probably the easiest way if you're dealing with perennials, things like trees. And so we mulch around all of our apple trees. And again, this soil is now very fungally dominated. We weed maybe once a year, and it's mostly just like grass that encroaches in from the side. There's just really not hardly any weeds, even in the sunny patches, because it's too fungally dominated. They don't like it. If you're going to do a cover crop, like for more of a vegetable garden, annual garden of some kind, use things like rye or Sudan grass, which are more kind of like, they're like our row crops. So they like a 1-to-1 fungal to bacterial ratio. Don't use radish and mustard, which like a 3-to-10, because they encourage what they want. So if you want a more fungally dominated soil, don't plant things that want a more bacterially dominated soil. If you're doing trees, you can do wood chips, but if you're going to do a ground cover, do other woody plants. Maybe, instead of planting, I don't know, clover as a ground cover, which is a fine ground cover, maybe do raspberries or blackberries that are also going to help push the soil to more fungally dominated for you. You can also, if you're going to fertilize directly, liquid fish is a great fertilizer. Liquid fish helps encourage fungal dominance because it's really high in really complex fatty acids that bacteria can't decompose very easily. Made a little, and inoculate with mushrooms. So this, around these trees here, we inoculated, these are actually wine cap mushrooms. So these are actually edible mushrooms, so we can eat them too, which is a win-win. But as they grow, they're also, again, increasing the fungal dominance of the soil for us. So they're increasing the fungal dominance of the soil for us, which helps the tree grow more, and also producing mushrooms for us to eat. It's great. And add fungally dominated compost. So if you're going to do compost, do a compost that's fungally dominated, which I'm going to talk about. If your plant wants a more bacterially dominated soil, maybe consider mulching with weeds. Like when you weed your garden, if you got a whole bunch of weeds piled up, throw those around them. because that's what they want. They want bacterially dominated soil. So that, I mean, they're going to encourage that too, like as a mulch versus like wood chips, which are going to encourage more fungus. If you're going to do a cover crop, the opposite of the fungus. Don't cover crop with rye or Sudan grass, cover crop with radish or mustard, which are both great cover crops and increase the bacterial dominance. If you're going to fertilize, things like blood meal are really good options. So the blood meal is one of the few that doesn't kill soil life. And it's a very easy to break down compound. Bacteria love it. And add a bacterially dominated compost. And so then the last one is they have to be there. So, if you've got, again, if you're trying to feed something that isn't there, good luck. And so if your soil has been tilled regularly, if it's had fertilizer applied to it, if you've applied any of the sides, herbicides, fungicides, pesticides, anything like that, your soil can almost certainly benefit from inoculating it with microorganisms, with bacteria, fungus, to get those populations reestablished, to get them there so that they can, grow and prosper and, repopulate the soil that you have. So where does the inoculant come from? Primarily compost and compost tea, which is just a liquid extract of compost. So the composting process is basically a buffet for all the organisms that were on the plant material in the compost pile. So, these bacteria and fungus are not like poofing out of nowhere in a compost pile. If you've got a leaf, there's bacteria and there's fungus on that leaf. You throw it in the compost pile. The compost pile is essentially just conditions to encourage decomposition, which means all those bacteria, fungi, even if they're dormant, will all of a sudden wake up and start eating. They'll start eating all those materials. They'll start multiplying, reproducing, increasing their populations. And you're mixing all these plant materials together and you're getting more diversity, hopefully. And so then when you spread compost or spray a compost tea, you are then inoculating the soil or the plants that you're spraying with the life that was in that compost. And so really the inoculant is coming from what is being composted, right? Because it's the stuff that's on those plant materials that are then composting. You're then extracting those to spray onto it. So if the stuff you're starting with doesn't have much diversity in it, neither is your compost, and thus neither is your soil, because different organisms like different plants. And so if you make a compost pile, and at the end of it, it might be gorgeous, beautiful compost, but if the only thing you composted was wheat straw, the only organisms that are going to be in your compost pile are things that like wheat. If you make a compost pile that is 100% wood chips, the only thing that's going to be in your compost pile is stuff that likes to eat wood chips of that species of tree. That's all you're going to have, which might be fine if you're trying to grow, if you're trying to grow wheat, that'd be a great thing to make potentially. But generally what we want is a really broad feedstock. We want to have as much diversity as possible in our compost pile because we don't know that much. We don't know that much about life, honestly. It's super complex, really diverse. It's beyond our comprehension at this point. And so for the most part, just throwing everything we got at stuff and then nature kind of sorts itself out is generally the best way to do it. So if you want a bacterially dominated compost, this is the easiest to find. You're in luck. Bacterially dominated compost is easy. Most compost that you can buy is bacterially dominated. And that's primarily because every time you turn a pile, every time you turn your compost, you're killing some of the fungus in that compost, just like when you till your soil. It's the same concept. And because of kind of regulations, which are important regulations to avoid the spreading of disease, but due to those regulations, almost all kind of commercial composting the compost pile is being turned pretty frequently. So the fungal populations tend to be really low. So at these composts, and so they also tend to be relatively sterile in a lot of ways, just because of the way that they're grown. So they are bacterially dominated. They're good to use if you need a bacterially dominated compost, but they're not generally super diverse. What they are phenomenal at, though, is adding that organic matter. Because like I said, you need at least 3% organic matter in your soil. This is a great, cheap way to do it, is that bulk compost that you can buy from places that you can get available. But it's not generally the best at getting a lot of diversity into your soil. So to get more of diversity, if you need a bacterially dominated compost, what's good is to have a little bit of vermicompost, so worm compost. When food goes through a worm, all the microorganisms in their gut go into their waste, and they've got lots of good stuff in there because they live in the soil all the time. And so vermicompost can be a great way, but it is bacterially dominated. If you're going to do it yourself, and really if you're going to buy it too, it's best to get it from a local source. It's best to get worms from someone who bred them locally, not just a store who has them locally that maybe shipped them in from California or Canada or something like that, because those worms have different microorganisms in their gut that are adapted to the place where they're at. There's different microorganisms in the soil everywhere, and so if you get one that's been living here for a while, they're going to have more of the local kind of microorganisms in their gut, and local producers are going to be having worms that have been here for a while because the worms are actively eating stuff. And so their vermicompost is going to be better than maybe bulk stuff that you can buy on the internet. You also, a lot of homemade compost tends to be more bacterially dominated, especially if you're primarily composting kitchen scraps and weeds. So, especially if you're doing like a tumbling composter, you're disturbing it a lot. You're killing off a lot of your fungus. Food scraps and stuff are generally mostly nitrogen, which is what bacteria really like. So again, you're just not going to get a lot of fungus, but it's a great, usually diverse source, especially if you're doing lots of kitchen scraps and weeds, you're throwing all sorts of different stuff in there. There's a lot of diversity that you can get in that way. And so you can kind of, till in a bunch of the bulk compost and then just do a light sprinkling. So when I say like inoculant, like you really need very little. Like there's some studies that have found that as little as a pound per acre can provide enough microorganisms as an inoculant. So like a light dusting is more than enough to inoculate. So if you want fungally dominated compost, which is what most people really need, most people have plenty of bacteria in their soil. Adding diversity is always great, but what most people are needing is they're needing to get more fungus into their soil. And it tends to be much harder to find. If you're wanting to buy compost, it's much harder to find fungally dominated compost for purchase because of those things that we talked about earlier. It's also generally more difficult to make in terms of you usually need to be more particular. Like if you've read up on compost and you see these things where it's like very specific ratios and very specific timing, that's generally to make fungally dominated compost. It's a little harder. Or on the other side, it can also be the absolute easiest compost to make, but just takes a lot longer, which is generally what I recommend. Low work, just a little bit more time is much easier than trying to learn whole new super complicated things. So it's usually best to make it. You can potentially improve existing compost. So if you have a bacterially dominated compost, you can do things to increase the fungal populations in it, which can be good. So just letting it sit for quite a while can be helpful. Just letting it sit so that the fungus that is there is not getting disturbed constantly can increase the amount of fungus. Letting it sit and adding some liquid fish to the pile can also help because again, liquid like fish is a great food for fungus, can help kind of increase the fungal mass in a compost that you already have. But if you're looking to make like one that is fungally dominated, like has a lot of fungus in it, the best and easiest way to do that is to do a static pile of woody material. And that's just where it's a compost of just basically all browns. So if you know like greens and browns in compost, browns are stuff that's already dead or like very woody materials. So if you rip off a living tomato plant, that's a green. It's green when you killed it. Whereas if your tomato plant is long dead from frost and it's brown and crunchy, that's a brown. And so like, dead leaves from trees in the fall, wood chips, those are all browns. And the reason that that's so good for fungus is, like I said earlier, fungus is the only thing that can break down cellulose and lignin, which is what's in those brown materials. And so what you usually want to do is you want to get as much diversity of browns as you can get. So wood chips, and ideally wood chips from multiple species. If you're able to do that, sometimes, that's hard to do if you're just getting a bulk drop of wood chips or something, but also fall leaves. And again, instead of just getting a whole bunch of oak leaves, if you're able to get like some oak leaves and some maple leaves and some, birch leaves, those are all going to have slightly different organisms on them. Straw, dead plants from your garden, and from varied places too. Even if you are able to get some wood chips, from one area, and then like somebody who cut down a different tree from another area might have slightly different stuff in it. And then fish waste, again, kind of that liquid fish can be helpful to add in there. Or I don't know, if you fish and you've got fish heads left over, throw them in. And then you mix it all together. So don't just put all wood chips and then, straw on top, and then like mix it all together and then wet it like with a hose, and then just wait. Um, and like a long time, like a year maybe, or even longer, which sounds like a long time if you want to do something now, but can be well worth it. And then to apply the compost, there's lots of different options that you can do. So you can just spread it on the soil, just like most people think about with compost. You can till it in, but again, you want to do that just as like you're inoculating the soil. You till it in, and then it's in the soil, and then you're good. Like you don't want to keep tilling. Um, or you can make an extract. So that's a great way to do it if you have a relatively limited amount of compost. And the way to do that is you can buy one of these bags. It's like a really fine mesh, or you can just use like an old like t-shirt or cheesecloth and make like a bag out of it. Put some compost in there, and you just dunk it in the water, like the bag with the compost in it. Dunk it in the water, and then like you can kind of see in this picture, massage it, like force the water in and out of it, smash it. Don't be like punching it or anything, but just like almost like washing it. Kind of like massage it pretty aggressively to get that water in and out, and that'll knock all those bacteria and fungi and protozoa and nematodes that are in that fungus out into the liquid. And then you can put the liquid in a watering can and water it kind of more evenly over an area than is sometimes easier to do with, or sometimes harder to do with like a solid compost. And you can spray that onto the soil. You can spray it onto plants directly. You can also soak seeds in it. Like if you have your seeds, before you plant them, you can kind of dunk them in the water and then plant them. And then they're right there on the seed coat for when it germinates. All right, so I know I'm running out of time here. Almost done. So the whole process then, with kind of what I talked about, if you're wanting to really care for the life beneath your soil, to kind of wrap it up here, you need to break up compaction and get soil organic matter to a minimum of 3%. And you can do that with cover crops, like we talked about. You can do that by tilling or broad forking. To the tilling and the broad forking to kind of break up compaction, but also you can do it to get kind of compost into the soil if you need to, um, as like a one time like breaking up compaction, getting the organic matter in there, and then you want to inoculate immediately. So you don't want to till and add compost in the fall and then inoculate 6 months later, because then that soil is probably compacted again. Because there wasn't that life there to build those micro and macro aggregates in your soil. So you want to do it, immediately. So if you've got that bulk compost and you've also got your really good fungally dominated or really diverse bacterially dominated compost, depending on what you're wanting, you can mix it in with that bulk compost and till it in, or broad fork it in, or whatever you're going to do to get it into the soil. It doesn't have to be a separate step. It could be the same. Or after you've tilled and broad forked the compost in, or after you've done the cover crops, you can then spray an extract on top of the soil. Um, and then to kind of maintain that, you want to then make sure that there's always food. So like we talked about, you want to do, succession planting in the garden. You want to use cover crops whenever possible, and you want to mulch whenever possible. And mulch can really also help fill in those gaps. If you've got, a spring crop and then it comes out, and then you've got another thing that you want to plant, but it's only going to be a month. Like there's not enough time to plant a cover crop, then mulch it really heavily. It'll also provide food for those plants. It'll help keep the soil cool and wet, and it'll help suppress weeds. So you mulch whenever possible, and also mulch in between your plants. Especially if you've got plants that have really wide spacing, like tomatoes, where they're like several feet apart and they're like this big when you stick them in. Mulch in between there. It's very helpful. Make sure to water during droughts. Use a broad fork or digging fork if you need to break up compaction or to till the soil to plant seeds or something. And then you can apply a thin layer of compost to plant the seeds directly into that, so that there's something maybe light and fluffy that's easy to plant in. And then if you do till again for some reason, or if you end up having to apply an herbicide, a pesticide, a fungicide or something like that, just kind of start the process over again. Just know that when you did that, you probably killed some stuff off, but now you know what to do. And so, reapply that compost or that compost tea or whatever, and then just keep doing what you're doing in terms of making sure that there's always food, making sure that there's water, all of the above. So for more in-depth resources on this, because I know I just ran through a whole bunch of stuff, a lot of what I got from is from some really phenomenal work that Dr. Elaine Ingham did. So she runs the Soil Food Web, but she used to work at Rodale. She was a professor for many years. She really did a lot of the initial work into the Soil Food Web. So she has a lot of good resources out there. There's also a professor down in New Mexico, Dr. David Johnson, who's been doing a lot of similar research. He's specifically been focusing though on bacterially dominated compost. So he has some videos and stuff online about the best way to do a compost pile to make bacterially dominated compost. He's done research on, what the benefits of that, all of that. NRCS, so the Natural Resource Conservation Service, also has a great book called The Soil Biology Primer that was almost completely written by Dr. Elaine Ingham. But because it's a government entity, it is publicly available. You can download it online and read through it. And also just as like a shout out, and also just to know all the traditional knowledge out there that I do not know about. There are, I'm only mentioning what I know, only what, I can find data on, what I've personally experienced, but we know that there's other things out there that can definitely help soil. I just don't necessarily know how, or there isn't data out there on how yet. Biochar is a great example that people have gotten really interested in recently. And we know it has to work because there are indigenous people on multiple continents who came up with it independent of each other. So it's obviously not just like some weird belief, like it obviously works, but we just don't know how, like how much to apply or when, or like they're still trying to figure that out. So there's definitely more stuff to learn all the time about this. And then just some last really cool numbers that I wanted to throw in there. So kind of the potential of this method, so that Dr. Johnson, that I said, has done some interesting studies. So he's the one who found that correlation of 5% versus 88% that I mentioned earlier between the fungal to bacterial ratio. He also did a 4.5-year field study of using fungally dominated compost. So these were soils that were bacterially dominated that he was increasing the fungal biomass in for row crops, which like more of a 1-to-1 bacteria to fungal ratio. And over 4.5 years of kind of applying this compost and doing these practices, he found the fungal biomass increased 25-fold in the soil. And on average, and this is wild to me, on average, the soil per acre per year sequestered 38,000 pounds of carbon, because fungus holds an enormous amount of carbon. And the yields doubled. So they're in cotton country in New Mexico. And this picture here is of a guy that was one of the researchers with him. On the left here, holding cotton using conventional fertilization. And on the right, it's cotton using the fungally dominated compost on soil that had been treated with it for 1.5 years. So you can see some pretty significant increases. Not that I'm promising your tomatoes will look, anything like that, but just to show that it is possible to do these things. And then there's just some interesting things from Dr. Ingham. So hopefully, go forth, shepherd your microflock in the soil, and grow great food. And then, yeah, we're Gateway Greening. Follow us.
Well, thanks, Dean, for that great presentation.
Yeah.
We do have a few questions that have come through.
Sure.
So we're going to try to get to all of them. So the first one is about potting soil. So putting mycorrhizal fungi added to potting soil. So it's not that useful for most vegetables and annuals. Is that true?
So it's not useful for your brassicas and your mustards. It can be useful for most of your other vegetables. So brassica family, mustard family, and again, you can look those up pretty easily. It's a lot of, your cabbage, kohlrabi, kale, collards, beets, or not beets, turnips, radishes, mustard greens, things like that. Those do not like mycorrhizal fungi. But things like tomatoes, peppers, eggplants, okra, sweet potatoes, those all like mycorrhizal fungi. And to the inoculants specifically, so inoculants are great. Like if you have them, but generally they're pretty selective. Like if you're getting it, you're usually getting like 1, maybe 2 species. Whereas if you are able to get like a bacterially dominated compost, there could be dozens of species in there. So if you have inoculant, it's great. If there's, potting soil that already has it in there, great, use it. But if you're able to get these composts, it's much cheaper, and you're usually going to see a bigger improvement using the compost that you make yourself.
All right, the next question is about temperature, and they asked during winter, is 80 to 85% of the tree's energy located in the soil? And they were curious because they've heard that in winter, most of the tree's energy is located near the buds.
Yeah. So kind of those numbers that are given are like of all the energy that is like being produced. So like during the growing season, the sun is hitting and there's you know sugars and stuff being made through photosynthesis. So that energy is being used to produce buds, to grow branches, to do stuff like that. But then it's also being used to grow roots, and then it's going into the soil. So that's an over the lifetime of the tree, not at a singular moment. So yeah, in terms of the energy that's like in the tree, in spring, a lot of it is at the buds as opposed to in the branch or in the root or something like that. But of all the sugars that are produced in total over the tree's life, that's kind of what those numbers were.
All right, next question. A few people asked, how do you test the FB ratio of your soil?
Yeah, so that is hard, which is why usually what is much easier is just to look at kind of what's growing in your soil, to kind of give you a gauge of kind of what direction you need to move it to. Um, Finding out the actual ratio, like the number of what your ratio is, involves like taking soil samples, using a microscope, being able to identify bacteria and fungi, being able to count them to get biomass numbers, which can be done, but it takes a lot. It takes a lot of equipment, and a fair amount of time to learn how to do. So generally, it's just better to know like, oh, I've got lots of lamb's quarters and like chickweed and stuff that is growing in my soil, so I'm probably mostly bacterially dominated, and I'm trying to grow something that wants more fungus, so I want to move it to be more fungal. If you really want to know, there are labs that you can send in soil samples to get tested, but it's relatively pricey. And one of the reasons why it's pricey is you basically have to do overnight shipping, because when you dig it up, the life starts dying. So it needs to get there as quickly as possible, to get a somewhat accurate number. And a lot of the testing labs you can find through kind of Dr. Ingham's website, the Soil Food Web. They've got kind of a list of all the different labs around. But as far as I know, there aren't any local labs yet. Most of them are on the coasts at this point.
All right, over winter, how do you till over winter cover crops without destroying the mycelium in it?
Yeah, I knew that question was going to come up. That is a phenomenal question. Um, so, so you can't. So if you're killing a cover crop by tillage, you are going to kill a lot of the mycorrhizal fungi. And there's actually been NRCS has done some studies where they found that if you're actually tilling in your cover crop, you lose almost all of the benefit of the cover crop, because when you till it in, you get an explosion of bacterial growth, and the bacteria off gas almost all of the carbon that the cover crop fixed into your soil. Fungi are much better at holding carbon in soil than bacteria are. So usually in terms of killing your cover crop, so you don't actually need to till it in usually. So you're really looking at killing it. So the best way to kill it is you can either do a winter kill cover crop. So you can do a cover crop that, when we get really cold periods, will just naturally die. So if you had done like a winter kill cover crop this last fall, it would have grown probably until, you know, 3 weeks ago, when it got down to the, double the, teens and single digits, at which point it will die, and then you won't need to till it to kill it. And then you can, do like a light dusting of compost on top and then plant the seeds directly in it, or just kind of pull the stuff that's left on top aside and plant there, and then just leave the dead cover crop as mulch. Or if you have an overwintering cover crop, what you can do is you can there's a thing called called crimping. So the Rodale Institute has done some really interesting research on crimping on a farm scale. On a garden scale, there's not a whole lot of data, but gateway greening, we've actually done some trials on that at our demonstration garden. We've a couple of videos that we did on that. I'm not sure actually where those are located right now, but if they're not on our YouTube, we can get them up there. But it's essentially where you wait until it's just about to flower. So like if you're doing rye or like a grass of some kind, you wait until like the seed heads are just starting to emerge, and then you basically just flatten it. Like you just kind of like smash it, knock it over, and you kind of you crimp it. So you don't cut it, but you take some like we just take like a 2x4 that's got like a piece of like fence post on it, like a metal fence post. So it kind of sticks down, but it's blunt, and we just kind of smash the grass with it to kind of hold it down, and then we cover it with a tarp. Which you don't have to cover it with a tarp, but it just makes extra sure that it's going to die. And we'll usually leave the tarp on there for about 2-3 weeks, and then we pull it off and it's dead, and there's just a big thick layer of mulch on top. So like for rye and vetch, that works really, really good if you're wanting to grow summer seedlings. So I love it. It's my absolute favorite way to grow tomatoes, peppers, eggplants, and sweet potatoes, because I grow the rye and the vetch. It starts to flower usually about the second week, third week of April. So usually then, I put the tarp over it. It usually comes off about the second week of May, which is about the perfect time to plant your summer cover crops. And then there's a big thick layer of mulch, and you can just make little holes, stick the tomatoes, sweet potatoes, something in it, push the mulch back around. And like for sweet potatoes, when I do it that way, I don't weed my sweet potatoes one single time all year, because the mulch from the cover crop lasts there long enough for the sweet potatoes to cover the whole soil surface, and then there's no weeds after that. It's glorious. But yeah, if you're actually needing to till your cover crop, you are going to kill mycorrhizal fungi. So it's if that's your only option, it's better to have the cover crop and then till to kill it than it is to have just bare soil. But yeah, we have some resources on kind of the rolling and crimping. And if it's not up on our YouTube and our website, I'll make sure to get that up there.
All right, the next question is it okay to bury kitchen vegetable scraps and eggshells in the garden through the winter? If so, can this be an alternative to cover crops?
It would not be an alternative to cover crops, because, well, so the potential issue with burying food scraps, as opposed to composting them first, is that food scraps for the most part are really high in nitrogen, and so bacterial populations get really high really fast on kitchen scraps, which is why most homemade composts are so bacterially dominant. And so what that happens is oftentimes when you're adding something like that and it's buried under the soil where there's not as much oxygen, where oxygen can't get in as quickly, what can happen is the population of bacteria can actually get so high so fast that it goes anaerobic, which is again where a lot of your pathogens come from. So it's better to compost those kitchen scraps and then apply the compost. So again, the best alternative to cover cropping, if cover cropping just doesn't work or you just don't want to deal with it, there's lots of reasons that people don't like to do cover cropping, which is fine, is to mulch. Just add a nice thick layer of straw or leaves from your yard. You rake up some leaves, throw them on your garden beds. That makes phenomenal mulch. The woods love it. You go in a forest, that's their mulch of choice. And look at how big the trees are. So yeah, I probably wouldn't bury it. I know like there's some systems, like if you're doing like bokashi composting or something, that might be a little different. But if you're talking about just like fresh kitchen scraps, I would not recommend that.
All right, and then how does tailing your FB ratio in the soil to the crop you want to grow work with crop rotations? And are you modifying the FB ratio each year?
Yeah, so that's the tricky part. The thing that's kind of nice with your vegetables though is that your vegetables are pretty close to each other. So that FB ratio, it doesn't have to be it doesn't have to be exact. You know, like plants can grow outside of that ideal FB ratio. It's just they really thrive when it's really like when it's specific. So there is some amount of shifting that you can do from year to year. But you know, if you look at that chart, let me see if I can find it here. There wasn't a chart, bullet pointed list. You know, if you look at here, you know, pretty much all of your vegetables are in these two categories here. So it's, you know, 3 to 10 and 3 to 4. So you know, if you're a 3 to 4, or if you're, you know, a um, you know, like a 2 to 5, or you know, or something like that, if you're kind of like in between these two, both are going to grow pretty well. But there is some tweaking that can happen. So for example, you know, if you do brassicas one year, you know, and they like that little bit, you know, lower amount, then and you know, and it's growing great, you know, you've got kind of a 3 to 10 ratio, then maybe, you know, over winter, if you do then, you know, a cover crop like rye or vetch, which likes, you know, a 3 to 4 or a 1 to 1, because it's, I mean, it's rye, it's right here, you know, it's going to help kind of push it that way. And then you leave that, you know, that rye mulch on top, and then maybe you fertilize a little bit with some fish hydrolysate, or liquid fish. You know, it'll maybe, you know, do that little bit of a push, so it's a little bit closer to that 3 to 4 for your tomatoes or your peppers or your eggplants. So there is a little bit of adjustment that you can do, but you can also, you know, think of the rotation in terms of just more, um, as almost like another layer to your rotation, which is not something that a lot of people want to hear. Um, but you know, if you're looking at just brassicas and mustards in one, you know, maybe, you know, do those in a couple beds. They're also really heavy feeders, so maybe they'd be great to have in a rotation where you're doing, you know, cover crops one year and then brassicas and mustard the next year, and just rotating those two in one bed, and keeping this, um, you know, that fungal to bacterial ratio, you know, a little bit more bacterially dominated. And then basically all of your other vegetables like this 3 to 4. And so they can, you know, do rotation just like they would have done before, if that makes sense. So yeah, it kind of makes it a little bit harder, but you can tweak it a little bit. But probably the easiest way would be to, you know, kind of have your brassicas, mustards, things that like more of those bacterially dominated soils, kind of in one rotation, and then kind of everything else in another rotation.
All right, Dean, can you add fresh grass clippings to help the fungally dominated woody pile break down faster for a better CN ratio?
um, you you can so you can so any of those nitrogens that you add, will definitely help it break down faster. The reason that the nitrogen helps stuff break down faster, though, is because it's food for bacteria, which are able to grow much more quickly than fungus. So if you do that, it will definitely break down faster, but you're gonna have a little bit more bacteria, which again is probably not the end of the world unless you're trying to grow an old growth deciduous or coniferous forest or something. Um, but like the general numbers that you'll see in terms of like, oh, you want 30 or 40% greens, and you know, 50 to 60% browns, that's not going to get you a really fungally dominated compost for the most part. It'll be much more balanced than just kitchen scraps will be. But you know, having um, so yes, so adding those nitrogens like grass clippings or kitchen scraps, will definitely accelerate it. But you don't want to go overboard. You want it to be mostly browns. You know, probably, you know, 3/4 brown at the least, probably. So like leaf mold. If you ever heard of like leaf mold, I mean that's literally just leaves that are piled up and left. I mean they call it mold because it's, I mean, fungus is what breaks it down, which is, you know, mold is a kind of fungus. Um, and I mean, and it just takes a year to do that. So you can add those greens, but that C to N ratio is a little bit more flexible than a lot of things suggest.
All right, one attendee asked, what can they do to rejuvenate their soil?
So I mean, it depends on what's wrong with it, but really kind of that last part that I talked about, you know, in terms of laying it out, you know, breaking up the compaction, getting organic matter in, inoculating the soil, and then keeping it covered. I mean, that kind of basic outline is really where it's at. I mean, that's really what can rejuvenate your soil, in a lot of ways. So I mean, there's lots of stuff out there in terms of like like specialty products that people are selling or buying that aren't necessarily bad, but in terms of like buying, micronutrient fertilizers and stuff like that, and adding those things is fine. But ultimately, if you don't have that life in the soil, it's not really going to be super rejuvenated. The life is really the way to do that. So you can do those things in addition to it, adding in azomite or stuff like that people do. Um, but kind of in my experience, and from when I've talked to people, and even when I've seen a lot of studies where they'll be like, "Oh, we added this, and we also implemented low till, or low till or no till, and it got better." And I'm like, "Well, did it get better because of the minerals you added, or did it get better because you weren't chopping up the fungus anymore?" Like, um, so it's kind of hard to say, but generally that outline here at the end of the presentation is my general recommendation for rejuvenating really any soil for the most part. Unless you're talking about like contamination. If your soil needs rejuvenation because it's got like radium in it or something, that's a whole different story. I don't know how to fix that.
All right, and then is it helpful to put used container soil into a compost tumbler to re-inoculate it for use in another season?
Yes. So you can so yeah, so that's definitely a thing that I didn't get a chance to talk about, but you can use good compost. Like if you make a compost pile that you're like, this compost is great, like it is full of fungus, or it's vermicompost that I know is really diverse in bacteria or something like that, you can then use that to inoculate soil that is not great. So I mean, you can inoculate your garden soil, but you can also use it to inoculate other compost. So yeah, kind of to what you're saying. So you could do it in reverse too. So like if you've got the potting soil, you can spray it with compost tea to kind of re-inoculate it, or yeah, mix it in. Or if you've got a pile, like I said, with the uh like with a lot of the compost you can buy that's relatively sterile, mostly bacterially dominated. If you then make a pile of really fungally dominated compost and you make an extract out of that, and you then spray down the that kind of sterile compost that you can get in bulk, and then you let it sit for a while, it'll become more fungally dominated, like because you're inoculating that compost just like you would be inoculating your soil. And then you have more great compost that you can then use to inoculate even more ground. So you can definitely do that for potting soil specifically. My only concern would just be that like if you're mixing it in with your compost, like if you're fully mixing it, that it might not have the same kind of texture that the old potting soil had, which might not be a problem. But depending on like maybe what you're growing or what you're used to growing in, like that might be uh, it, it might be difficult for you to adjust, if that makes sense. Like if it's all of a sudden not as fluffy as it was before, and you then need to kind of like relearn how to grow stuff into that. That's not a problem, but it is just something to consider.
All right, Dan, this is the last question of the night. Somebody said that they heard that it is good to leave plant roots in the soil after the plant is done producing to help maintain soil communities. And do you know if there's another way to increase fungus in the soil?
Yeah, so I mean, leaving the roots in definitely helps in the sense of in a couple ways, in that I mean, it's organic matter, so they can so the plant isn't actively releasing exudates anymore because it's dead. But it is organic matter at that point that the bacteria and fungi can then eat. So that's good. It's also helpful in that when you're ripping the roots out, you're also breaking up the soil. I mean, it's kind of like a little mini tillage event. So if you don't need to rip those roots out, then yeah, not disturbing the soil is better. Um, and then yeah, I mean the other ways to encourage fungus in the soil are a lot of the same stuff that I talked about, in terms of using a fungally dominated compost to inoculate the soil. Um, if you're going to do a fertilizer, to do one that encourages fungus. So particularly fish fertilizers are good at that, and particularly liquid fish. So not fish emulsions, which the difference is is relatively small. I mean, it's basically fish emulsions, which is what most people find for fish fertilizers, have been heated, and so when they heat, they break the really big molecules break down into smaller ones, and so fish emulsions actually increases bacteria more. Liquid fish is just literally like a fish that went in a blender until it was a liquid. Um, It's real gross. Um, but if you're able to find it, fish hydrolysate is one where it's been like processed a little bit more. It's not quite as gross, but is still good for fungus. And then mulching with high carbon things. So keeping mulch on the soil that is that's woody. So straw, dead leaves from the fall, um, wood chips if it's appropriate. I wouldn't use wood chips necessarily in a vegetable garden, just because they can be kind of hard to deal with because they're big chunks. Like it's hard to plant seeds into wood chips. But things like that are generally the best to encourage fungus.
All right, Dean, we actually got one more question. It's a very good
Sure.
question. If weeds are growing in your compost pile, does that mean that there's too much bacteria in your compost or weed seeds in the compost?
Ooh, yeah. So I mean, it definitely means there's weed seeds in the compost for sure. Um, it probably means that it's bacterially dominated. Yeah. Like if you have a big pile of wood chips, you usually don't see many weeds growing in it until it's been there for a long time. Um, because it's pretty fungally dominated. Also because it's not like soil, um, but yeah, it probably it means that to some extent. I mean, your your compost is always going to have some bacteria because bacteria are what grow there first. I mean, you're never going to have 100% fungus, and that was even in that like ratio that I gave you. Like the things that like the most fungus, it's 1,000 to 1. There's still that one. So it could be that there's just like a little pocket in the compost too that is bacterially dominated. But yeah, like if your whole compost surface, like if there's weeds all over it, it's almost certainly, yeah, pretty bacterially dominated if it's growing that happily. But if it's just like, oh, there's one weed here or there's one weed over there, um, it doesn't necessarily mean that the whole pile is bacterially dominated. But yeah, like if you've got a pile of your compost and there's just weeds all over it, it's bacterially dominated for sure.
All right, well, that's all the questions for the night. Thank you, Dean, for this wonderful presentation. And we did get a few comments about some services and some products, and I will make sure to pass those along to Dean so that he can check them out. But thank you all so much for attending our 12th annual Community Ag Conference. We really appreciate it. Again, we will put this conference or this workshop on our YouTube page. Give us about a day to actually get it uploaded on there. And we hope to see you all tomorrow night for our keynote presenter. All right, thanks so much. Have a great night, everyone.
Yeah, bye.